Hi, in this video we will learn how to find the distance of a point from a plane. So the setting is that we have a plane in R3 and we have a point B. Well, let me denote this plane by curly P. And we want to find the distance. Distance of that point from the plane is the same thing as the distance of or the length of the line segment which starts from B and it is perpendicular to the plane. Well, also you need to remember that for planes we had this normal vector which is perpendicular also to the plane. So you have two things perpendicular, so they are parallel. Now to find the length of this line segment here, the trick we use is very nice, that we pick any point A on the plane and then find the vector AB. This vector now is a vector that if I project that vector AB on the normal vector, I am going to get exactly is a vector. I'll get a vector whose length is exactly the distance of B from the plane. So in other words, projection of AB over the normal, this is a vector. If I find the length of that, this is going to be the distance of the point B from the plane. So that is the formula. Let me write it here because we will use that. So distance of B from P with normal vector N is equal to the length of projection of AB over N, where N is where A is any point on P. Just that simple formula. So through example we see how this work. Find the distance from point B, which is 1, 2, 3, to plane x minus 2y plus 2z equals to 1. Okay, so I will draw this like that one. So the equation given for the plane is in the general form. So we have right away we can find normal vector. Normal vector is given by the components of normal vector are coefficients of x, y, z here. So -2, -2. So 1, -2, and 2. This is a normal vector. How about a point? So any point you choose. So we need a point. Any point you choose. Well, here means what? Plug in any values for two of the variables. The third variable, solve it for the third variable, and that will give you a point on the plane. Well, I can do y equal to 0, z equal to 0. As a result, we get x minus 2 times 0 plus 2 times 0 is equal to 1. That gives us x equal to 1. So the point we will use, or we will work with, is 1, 0, 0. Very nice. Now I have a point on the plane, I have normal vector, then we can find AB. This is the position vector of B minus the position vector of A. This gives us 1 minus 1, 2 minus 0, 3 minus 0. And this is 0, 2, 3. This is the vector. Now we have to find the projection of the vector AB over the normal vector n. Remember the formula, n dot AB over n dot n, and then that's a number, scalar multiplied to n. Well, here in this case, we have what? Normal vectors 1, negative 2, 2. Dot AB is 0, 2, 3. And 1, negative 2, 2. Dot 1, negative 2, 2. And then the number you multiply to this vector. Here in the numerator we get 0 minus 4 plus 6. In the denominator we get 1 plus 4 plus 4. 1, negative 2, 2. And what is that? This is 2 over 9. So let me just scale and multiply. 2 over 9 here, negative 4 over 9, and 4 over 9. So that's the second step. And then, well, the distance of the vector B from the plane is going to be length of this projection. Length of this projection, which is, well, square each component and then add them, find square root. The numbers are not bad. Here we get 4 plus 16 plus 16. All of them are over 81. So simplify. This is 36 over 81. Divide both by 9. So you get 4 over 9. Square root of that is 2 over 9. So the distance of the point 1, 2, 3 from the plane x minus 2y plus 2z is equal to 1 is equal to 2 over, well, not 9, sorry, that is 3. 2 over 3. Very nice. So the first remark comes in is that, well, this formula works also for a line in R2 and a point. So we can find distance of a point B in R2 from a line L with normal vector N and a point A on the line. So what we do is just again do the same thing, projection of AB over the normal vector. This will be the distance of the point B from the line L. The key point is here that in R2 also you have normal vector. You can use normal vector to define a line. And this formula basically works for everything that you have a normal vector to define it. Okay, very nice. Let's do an example. This is an example actually we did in another video for the distance of point from line. So find the distance from point to 1 to line x minus 3y equals to 1. Well, again, so x minus 3y equals to 1 is in the general form. We can find the normal vector. This is the normal vector. A point on the line. Well, again, any point you can choose. Well, I would choose the one that I used in the other video. So we set x equal to -2. This will be -2 minus 3y equals to 1, which is -3y equals to 3, and y is -1. So the point A that we will work with is -2 and 1. Now we have AB, which is 2, 1 minus -2, oh, -1. Oh. And that gives us 2 minus -2, 1 minus -1, which gives us 4, 2. Okay, very nice. 4, 2 is there. Now we find the projection of this guy over the normal vector. So this will give us n dot, well, it doesn't matter, n dot AB or AB dot A. The dot product is commutative. We find that number and then we multiply by the normal vector. AB is 4, 2. Normal vector is 1, -3 over 1, -3 dot 1, -3. When we find the result, we scale and multiply to the vector 1, -3. Here we have 4 minus 6 over 1 plus 9, 1, -3. So that's -2 over 10, well, -1 over 5. This is 3 over 5. Very nice. And then the distance of the point B from the line L is going to be the length of this guy here, which is -1 over 5 squared plus 3 over 5 squared. This gives us 1 over 25 plus 9 over 25. And that is 10 over 25. This is exactly the same number that we found using the other formula. This is root 10 over 5. Very nice. And well, the final remark is an interesting remark because it will give us a nice formula remark. When we find the n, the projection of AB on n, in the numerator we have n, or AB dot n, doesn't matter, the same thing here. So here I can write this guy as what? AB is the position vector of B minus the position vector of A. Yes, and this guy is n dot here, n dot B minus n dot A. Remember, A is a point on the plane. And if you have a point on the plane and you have normal vector, remember the equation you find is, so the equation will be n dot x equals to n dot, well, here I'm not using that point P, but A. Here you see that we have in very similar situation. Instead of x, we have plugged in b here. So in other words, this is n dot x minus n dot point A when we plugged in x is equal to b. And well, if you expand this part, in the regular case, you get ax plus by plus cz equals to a number. Now we are bringing this d to the left hand side, and we are plugging in components of b instead of x. So here what we will get is ax0 plus by0 plus cz0 minus d. And well, that gives us a good start of a problem that you will receive for the first series of assignment that says that prove that the distance of point B equals to x0, y0, z0 from plane given by ax plus by plus cz equals to d is equal to, so d of this guy is equal to, so you apply this remark and a little bit more things, you will see that you have absolute value of ax0 plus by0 plus cz0 minus d, absolute value, over square root of a squared plus b squared plus c squared. This is length of normal vector actually. And similarly, we have the distance of point B x0 y0 from the plane, from the line ax plus by equals to c is given by, so b and l is given by absolute value of ax0 plus by0 minus d over a squared plus b squared. Well, the examples we had, we can apply this formula. These are two new formulas. Well, special cases of what we had. Example, we'll find the distances of what were the examples. So B was B was 1, 2, 3, and the plane was x minus 2y plus 2z equals to 1. Then right away you can do the formula. Yes, d of b and the plane is equal to, well, plug in the components here and you get 1 minus 2 times 2 plus 2 times 3. You have to bring that d to the left hand side. Also, you need to put absolute value. Sometimes this might get negative number there. And then in the denominator, you have 1 squared plus negative 2 squared plus 2 squared. This gives us what? In the numerator, we have 1 minus 4 negative 3 plus 3 plus 6 is 3 minus 1 is 2. So absolute value of 2 is 2. In the denominators, 1 plus 4 is 10, and that is 9, and that's root 9. So this is 2 over 3, the same number that we got in that example. Let me just quickly show you. This is the same number, yes, we found here. Also, in the second example, for the distance of point 2, 1 from x minus 3y equals to z, we can use the same formula also. So this is distance of point and line is absolute value of 2 for x minus 3 times 1, and we have to bring this negative 1 to the other side, over 1 squared plus negative 3 squared. In the numerator, we get negative 2, absolute value of negative 2 over root 10. And that is 2 over root 10. And well, the number we got up there is what? The number we got up there is here, root 10 over 5. If you rationalize this guy here, you get 2 root 10 over 10, which is the same thing as root 10 over 5. Root 10 over 5. So this way we have a formula which is close. So you don't need to do any of those projection things, although you need to understand the mechanism here, how we find the distance. Okay. So this was the video in which we did the distance of a point from a plane, or in general an object with normal vector.